I mean, that's a chorus.
Hell yeah. Pretty crazy, right?
That's... I'm just picturing the ground covered in various species of frogs.
Yeah, I think it's pretty intense set of circumstances.
That's incredibly intense. It was amazing.
So there are a couple of different species here. If you can get either of them, I think there's probably more than two, but I know what two of them are. So there's that, like, if you can get that one, you can have a point. And there's another one which is like, it starts with like a wee, and then it goes. See that?
Oh yeah, I hear it. That almost sounds insect-like.
Yeah. So that is the other one. If you can get either of those.
And then there's also this wah wah noise in the background.
Yeah.
Oh my gosh. Do I get any clue to narrow this down through the cacophony of frog screams?
It's a country I've recently visited that I haven't stopped banging on about.
Oh right, so Costa Rica.
Yeah.
Okay. Is one of them buried in there the mountain chicken?
The mountain chicken frog's from like Dominica, isn't it?
Are they?
Yeah,
they might be.
I don't think they're from Costa Rica.
God damn it.
Sorry, Ben. I might be wrong about that. wait, let me just say mountain chicken frog. I'm sure because I saw them at the zoo the other day. Sure, they're from native to the Caribbean islands of Dominica and Montserrat. Yeah, so no, it's not.
Okay, so I don't know what I'm talking about.
Not bad though. It was
okay.
Like,
well, I'm gonna double down and say that one of those was at least a Leptodactylus.
No, unfortunately not.
God damn it.
So the one which is like a wee, that is the yellow toad, Incilius luettii.
Okay.
Do you remember we did that paper about the animatronic toads? They like built the models.
Oh my gosh, yes, that was incredible.
It was that
the robotoads.
Yeah, the bright yellow.
Oh my gosh, what a study.
Bright yellow toad. So the males are yellow, the females are brown, and there was that paper by Rehberg, Bester et al., which showed that males use color to discriminate their mates in like a big mating ball kind of setup. Like the males just grab the brown ones, they're yellow. So yeah, those little model toads were super cool. If you're listening, please send me one. And the other one, the like, that is the Mexican burrowing toad, Rhinophrynus dorsalis, which I think we may have had possibly as a call before, but I might just be getting mixed up with something else. But
I don't know. We're getting to the point that I've absolutely fully forgotten frogs that we have had on the podcast. Like it's just so far gone at this point.
Yeah, well, I mean, I can't remember what happened 5 minutes ago, so there's no chance of me remembering that. Yesterday, I was out training some undergraduate students on how to do radio telemetry, and I'd hidden a bunch of like fake animals with radio tags around the woods. And they were like, are we getting close? And I'm like, I have no idea. I put these out 10 minutes ago. I can't remember where I left them. You better be able to find them.
The stakes have suddenly been risen.
Yeah. Luckily, they were quality, so they found them all. I didn't even have to go around and actually demonstrate my radio tracking skills at all. But yeah, these Mexican burrowing toads, Rhinophrynus dorsalis, they're just straight up weird. They've got that like super flaccid skin, short face, fat body. They barely have a venture above ground except when it rains. So this cacophony of calls was actually sent in video form by my friend Theo, and in the video, one of the Mexican burrowing toads is like walking around, and it's so funny, man. Like the way it walks is literally hilarious. It's just this like pudgy little character. It just looks like it's not meant to be on land.
So the real question: how many frogs are visible in the video?
It's not a crazy amount because like Theo's quite close, so he can just see like a few, but you can just hear that there are more. He sent me a bunch of videos. I think he's working at Santa Rosa National Park in northwest Costa Rica. And yeah, I think there was just some rain and this pond filled up, or a series of ponds filled up, and he went down there and shot a bunch of videos. Theo's like a tree expert, but he's becoming a herpetologist. So there's hope.
Well, I mean, when you've got that many frogs and the screams are that loud, you can hardly ignore them, can you?
Yeah, no, exactly. But yeah, there's a picture of Theo on my Instagram in front of a boa that we found. So that's Theo, if anyone's curious. But yeah, thanks Theo for sending that in. That was super dope. Took me a while to get around to it.
That was wicked cool.
Yeah, really, really awesome. One of those ones where you can kind of like picture being there. So let's move on.
Yeah, I think I was going to say it's sort of a soundscape sort of thing, but it's so overwhelming that it's not exactly white noise.
A little bit too much. Let's move on, shall we, to our main paper for today. We're talking about blind snakes. Blind by name, blind by nature. So this is a paper by Tiatragul, Skeels and Keogh, Morphological Evolution and Niche Conservatism across a continental radiation of Australian blind snakes, published in Evolution. So this is a big study. What's the genus of blind snakes called? Anelios.
Yes. And I definitely haven't misread it in my mind as Anolis multiple times. Definitely not.
Well, no, yeah.
I haven't done multiple double takes of like, now they're talking about lizards, what?
Yeah. Anolis is obviously, more famous, but Anelios, they're coming up. And this was, this is a study which we've been waiting for because I saw a talk by Tiatragul in the World Congress of Herpetology. He presented an awesome presentation about this upcoming publication. And it was really funny and just like super well done, really entertaining talk. One of my favorite ones. So we mentioned it in the World Congress of Herpetology episode. But yeah, essentially they looked at a bunch of museum specimens of these Australian blind snakes, and they were trying to work, but they also knew the kind of relationships, or they worked out the relationships between the species genetically. And they were looking basically to see, okay, in Australia, we've got 46 endemic species of these blind snakes. Why are there so many species? How are they different? Like, are there sort of patterns?
Why are they different?
Yeah.
When did they become different?
Yeah. Are there patterns in the differences between these things that you can relate to, like either the environments in which they're found or the sort of phylogenetics, so how related the species are to each other. And obviously these are blind snakes, so they're completely fossorial. They live underground. A lot of them eat insect larvae and that kind of stuff. It's not the most glamorous of existences, but it's very important, and they are really cool. And they're way more varied than you would think as well. Like, I don't know about you, but when I think of blind snakes, I just think of like, okay, it's probably black.
Blind snake.
Yeah.
Job done.
It's either black or dark brown.
Spaghetti.
It's a bit spaghetti-like, and it looks like a worm until you touch it, and then it's a snake.
Yeah.
Basically.
Yeah. Tiny little faces, no like separation of head, like almost uniform, perfectly uniform width the entire way.
Yeah, and quite a rounded head generally, but not always. But yeah, I think this is one of those papers which is like pretty complicated, to be honest. I found it quite hard to understand. But
and you've done more genetic stuff than me.
Is that true now? Maybe. Yeah, maybe. That doesn't mean I am.
Right?
Yeah,
I think
suppose.
It definitely is.
Yeah, I think, yours are just out, whereas mine are still being worked on. But yeah.
Well, you say that like I've got plural. No.
Well, you did a genetics paper, which I was impressed by. I've been working on one.
One genetics paper, yeah.
I've been working on one for like 5 years. Actually, I'm working on a couple of things now. So yeah, there will be some genetics papers.
There we go. So this is all you. Yeah, you're responsible for understanding this one.
I wouldn't go around telling people I knew more about genetics than you, though, for sure. Like, I think we're on about living pegging. So
no one would fight you on it.
No one would know. But yeah, so basically, it's just both of us trying not to take responsibility for feeling like we haven't really fully understood this. But we did manage to pick out a few like tidbits of information. I think the paper does a
good job, at least, sort of highlighting the takeaway. So we should be able to communicate the findings.
Yeah,
at the very least.
Yeah. So I think we just talk about some of the cool things they picked out, really, rather than getting too bogged down in like the ins and outs. One thing which I really liked, which was kind of one of the things which was mentioned at the World Congress as well, is that skinnier species. So these things can either be thin, little thin and long, or they can be fat and short. And in the presentation at World Congress of Herpetology, Tiatragul was basically likening them to either spaghetti or sausages, which Australians call spags or snags, because there's spag is the Australian slang for spaghetti, and stag is the Australian slang for sausage. So it's very funny. You know, they're either spags or they're snags. They're short and fat or they're long and thin. And it turns out that there are some kind of sort of ecological determinants, it would seem, of these two kind of different body structures. So the skinny, thin ones...
Reasons for being that shape is what you're getting at.
There's reasons it benefits them in certain ways. So what they found was that the skinnier species tend to occupy areas with soil which is harder, so it's more difficult to burrow in, which they said was surprising, because you'd think that a larger, stronger blind snake, you know, if it's fatter and stronger, it should be able to dig more effectively than like a little thin species. But
yeah, I guess I would have kind of, I mean, to me, the skinnier makes sense, right? You've got less to push through. You need to push less dirt out of the way. And if that's harder, you make yourself smaller.
Kind of, yeah. Right? But if you imagine, like, you know, when it's like
how pressure works?
You know, when it's been like really dry and the soil is super hard.
Yeah, like compacted rock solid sort of.
Yeah. I feel like a little pathetic thin blind snake is going to be impenetrable, right? Whereas a fatter one, you'd think it would at least have a chance of like clawing out.
Right, but think about, okay, you know, you've got a nail that you're pushing into the dirt versus a pin.
Yeah, but that's not a good analogy, because it's more like a pencil versus a... I suppose it is a kind of a good analogy. It does make what you're fundamentally saying makes sense. The thinner the point, the easier it should go in.
Right.
But they don't think that's why this relationship occurs. They don't think it's anything to do with the ability to dig. They think it's because thinner species might rely on existing burrows or insect tunnels, so they can fit in the existing tunnels made by small insects. Whereas the fatter ones, they don't do so well where the soil's hard to burrow, because they can't fit into the burrows of other animals as well. So they rely on being in softer places.
And it's hard to dig anyway.
Yeah, so they rely on being in like softer, wetter places where it's diggable, and the big fat chunkers can actually like get a purchase and get down into the ground. Which makes sense. So thinner species, harder soil generally, because they're using existing burrows.
Suggest any other benefits for being sort of, as they call it, robust body ratios?
Not that I can recall.
What's this? Yeah, I'm just wondering whether it's a like relaxation of the requirement of being skinny to get through these sort of insect burrows, or whether they're being pushed towards being sort of bulkier because it's got different benefits. I guess maybe better surface area to volume ratio, just in general, might make them sort of less vulnerable to sort of perturbations and variations in climate and stuff.
What, like less likely to dry out because they've got more water in them?
Yeah, maybe.
Makes sense. I mean, kind of, yeah.
But then they're in also more humid areas anyway, so...
Yeah, I could also see it being like, maybe the fat ones can... Because, you know, they're, to some extent, they're gape limited, right? They can only eat things as big as they can swallow. So the bigger ones can eat bigger stuff.
Yes, they do. No, sorry, they do suggest that they follow Bergman's rule, right? So bigger ones, colder places, which is an efficiency thing.
Right.
To prevent heat loss, right?
Good knowledge. Good old Bergman. I wonder how he's doing.
Yeah, there you go. They do bring it up in the discussion. I do have it highlighted there. Okay, that makes sense. Cool. Okay, yeah. That's so probably where my question came from, was vaguely half remembering that.
Well done. So yeah, so it might be better to be fatter because they are like less vulnerable to drying out and stuff. And if they can get bigger, they just do get bigger. Yeah, makes sense. But yeah, so broadly though, just looking at like all the relationships between all these 46 different species, they were looking to see if they'd kind of like varied greatly across space and like phylogeny and their relationships. They were looking to see if there was like a lot of variation. And it was kind of interesting because broadly speaking, what they found is that if blind snakes are closely related, they only tend to show quite relatively slight differences in body shape, and they kind of tend to stick to similar habitats. So we call that niche conservatism. So although they're different species, they're inhabiting very similar places. Also, there's very little overlap in the areas they live. So it tends to be that species are geographically separated. So when one species ends, another species begin. And that is kind of indicative of species like diversifying simply because they're separate rather than because they're filling different ecological niches. So they call that non-adaptive radiation. So new species are forming without, significant changes to their like behavior or ecology. And they think that one of the reason, or like the most likely reason why all these species are kind of quite broadly similar is that the arid zone of Australia where these things are found is relatively young. It's only 2.5 million years old. So this is quite a new radiation of snakes. And what it looks like is that these animals have arrived, spread out, and as soon as they've spread out, they've started speciating, becoming different, based largely on the fact that they're separate from each other. So it's like, it's not like
it's
they're
through this sort of allopatry, this isolation.
Yeah, they're not like necessarily adapting to sets of specific circumstances, although they are to some extent, but that's not like the driving force behind their evolution. It's more to do with, this geographic separation. Maybe there's some sexual selection, maybe it's selection for mates. It could also be just genetic drift. So the fact that they're separate, they gradually become different over time. They're not mixing
I can't
anymore.
imagine the dispersability of these little guys is particularly dramatic. So I imagine it would be quite easy to isolate a population with, I don't know, a decent sized sort of mountain range or a puddle.
Yeah, well, this is the thing, though. I could see them they're really small, aren't they? And they live in the soil. So maybe I could see them getting transported down like water courses and stuff. Like if there's like a load of rain, they just wash
down drainage basins sort of stuff.
And they could find themselves quite far away.
Washed out in a storm.
Yeah. But anyway, really massive study and a hell of a lot of work went into this one. And it's one of the kind of better, it seems to me, I'm not an expert in non-adaptive radiation. I find it really confusing, but they seem like they're a good case study of this phenomenon where they're kind of becoming different species despite not actually being very different to each other and despite living in broadly similar circumstances, despite what we said about the skinnier and fatter ones at the beginning. But anyway, this is one of those ones where I kind of hope we've done it justice. Maybe if you're listening and you think we've slightly misrepresented it, then get in touch and we'd love to hear from you.
But we do recommend checking out the paper itself too, if you're that way interested, because there's a lot of detail in here that is really awesome.
Yeah, really nice figures. But anyway, super cool study. And I could just read about blind snakes. I could do blind snakes. Probably not every week, but I do like them. They are cool.
Definitely not. No. Can't do anything every week.
No, we need some twiddles.
Reasonable.
All right, cool. Well, should we move on to any other business? Because I think we've got a few things to get through this week, haven't we?
We do have a little bit, yes. What would you like to start with?
You tell me, Ben. I don't mind.
Well, should we start with some crocodile business?
Yeah, let's talk about Cassius. Okay, so Cassius, we talked about him 2 episodes ago now, and he was the largest saltwater crocodile in captivity, the largest crocodile in captivity. He was massive. He was like 5.5 meters long. Is the whole thing. He died
with all the photos that looked like they weren't real, and
he was real. Unfortunately, he died pretty much of old age. But anyway, he's back in the news because a team of scientists are trying to determine his age. And like, this is a thing which is super difficult to do with reptiles, right? Work out how old they are. We just don't know. Like, if you
they're not like trees.
No, they're not like trees. They're not like, I know you hate it when I talk about fish, Ben, but fish have a really easy way of aging them. You can just look at their little cheekbones.
Unless you ask them.
And they have growth rings in their otoliths, which is their little cheeky bones. And if there's like phases of growth in a year, it like gets put down as like a new thing of bone. So
they've ripped off trees, is what
they've ripped off trees, yeah. Trees, which is older though, trees or fish? Ooh, probably trees. Don't know though. But the the whole thing is that reptiles in general are difficult to age. There was this one study ages ago where somebody cut I think it was a veiled chameleon's toe off after it was dead and looked at the growth rings, and they reckon they could age it using that. But scientists are trying to do that with Cassius to determine, is he really 110, 120 years old? Will it work? One scientist in this article in Smithsonian magazine was suggesting it wouldn't work because they live in quite a climatically stable environment, so you may not get that period of growth.
The distinct seasonality that creates a darker and lighter growth parts. Yes,
exactly, because like the bone is comprised of different things, I guess. Not exactly sure why that happens, but yeah.
Well, I think it's different densities and things, right? Different mixes of elements, or probably isotopes.
Ooh, the isotopes. Yeah. So anyway, Cassius, we may or may not determine his actual age, which would be really, really cool if we could. I got some more news. What's up next?
Oh, but before we move on, do you know if crocodiles experience senescence?
I mean, I assume they do of some description. Yeah. Like, don't all animals have some kind of senescence, which is like the late aging bit where they get a bit rubbish, really. Like, it's famous for things like octopuses that have it as they're guarding their eggs. You know, they just get all floppy and loose, and then they just slowly deteriorate and die.
Well, yeah, octopuses have quite extreme senescence, don't they? They have quite short lives. I think there are some things that don't have as obvious senescence, because I think lobsters are one of them.
Oh, what? They just don't age?
Well, I think the issue with lobsters is they have greater and greater trouble getting out of their molted carapaces.
Is not getting stuck in your own skin a kind of pathetic senescence?
Yeah, I mean, almost certainly if you want to sort of broaden the definition of senescence, but like...
What is senescence defined as, though?
I think sort of genetically it's less obvious in them. I'm just wondering with crocs. I mean, it's just... I just wondered if you had a quick, like, yes or no on it, but if you don't, we can just...
I don't. So it's the process of aging at the cellular level.
Yeah.
Senescent cells don't divide. They stay alive, but they don't divide. Interesting. Okay, there you go. It's different. It's slightly different than aging, but yeah. Okay, cool. But I don't know about crocodiles and senescence. So what else have we got?
Yeah, we'll leave that open. I don't know. I don't have anything. This is all on you, mate.
Yeah. Is there not a picture? Is there not something to do with brown snakes?
There might be. I can show you a picture of brown snakes.
Yeah.
We've got a picture of a brown snake eating a different snake.
It's actually two eastern brown snakes. So this is Pseudonia textilis. And this is a picture sent in to us by Trinder. So thank you, Trinder, for sharing this with us. And it's cannibalism in eastern brown snakes, which is thought to be...
for those without the picture, it is just two snakes, one eating the other head first.
Yes, one has kind of gobbled
similar
up,
sort of sizes. I'm sort of guesstimating from looking at the sort of body chubbiness.
I think the victim's a little bit smaller.
Marginally smaller.
Yeah. But eastern brown snakes, they're known to eat reptiles, although as they get older, they tend to sort of focus more on mammals, but they are known for eating other reptiles. Cannibalism has been recorded, but is not common in the species, or at least it's not as far as we know. So pretty cool observation by Trinder. And thanks for sending that in. Nice to see. Well, it's kind of weird to see two snakes eating each other, but I find cannibalism really interesting
to see.
Yeah, cannibalism's a weird one as well, because you'd think it's like maladaptive to just eat other members of your species. I mean,
why would you think that?
Well, because you're reducing the number of individuals you can potentially mate with. Surely, are you being sarcastic? Surely it's obvious.
No, I was just being purposefully difficult.
Okay, cool. Yeah,
but it's also your nearest competitor.
It is also your nearest competitor.
They take up the same niche as you. Get them out of here. What a better way of defeating an enemy than consuming their energy and claiming it as your own.
True that, man. True that. Yeah, true that. Yeah, I've often wanted to do that with my enemies, but it's just not sort of socially acceptable. But I think one thing that's interesting about this would be to know whether or not these are males or females. It's thought to be less common for males to eat females, but I mean, that might just be nonsense. Don't know. Interesting observation.
It's one of those that's really hard to sort of, you talk about it being assumed to be maladaptive and stuff, but it's so hard to get a handle on because it's so rare, almost so rarely observed, and we sort of assume it to be quite rare in a lot of species anyway. I'm sure I think there are some lizard species that it's reasonably common.
Yeah. And like crocodiles will do it quite a lot.
Crocodiles will do it quite a bit, yeah. But you'll see, you'll see behavioral differences in how they sort of deal with ones that could eat each other. It's come up in the cane toad stuff. There was that whole cane toad study of them shifting, the juveniles shifting when they were active to avoid getting consumed by larger adults and stuff like that. So
I think that's what's rarer.
Yeah.
I think it's more uncommon for it to be two animals of the same species that are both adults doing it. Rather like juvenile phases.
Yeah, the juvenile adult thing, yes, definitely comes up. Whether that's maladapted, I don't know. I mean, in some ways it could be a benefit because it's sort of, in this weird, like, aggressive Darwinist sort of natural selection kind of way, maybe only the weaker individuals get eaten and therefore just sort of eases the population overall. But that's kind of got a horrible brutality to it.
Yeah, there's so many facets to this as well because brown snakes are pretty tolerant of like really heavily disturbed environments. And I think there's some evidence to suggest that like in faunas which are like less varied because of human habitats, like basically where there are a lot of humans, there are less species, only relatively few species are abundant. And therefore these things could be pushed into competition more because like brown snakes will live on farms. Maybe a lot of their other prey won't. Yeah, who knows?
Right.
Anyway, interesting picture. Let's move on to our...
Very interesting. So many questions.
Yeah, let's move on to the picture sent in by Christopher McLaughlin. So this is a couple of images here of Terrapene ornata, the eastern box turtle. So we were discussing the boldness of western box turtles back in episode 210. And this came with some discussion of how being bold in urban areas might not be good because if you're too bold, you might just walk into the road. Boldness is kind of associated with moving around, exploring new things, being a little bit more adventurous, which could be dangerous if there are roads and other hazards. Well, sure enough, this little guy, although it's the other box turtle, it might have just got away with being bold, really, because you can see this is a turtle which has survived a massive impact from some kind of cutting machinery and healed up.
Yeah. I think so. Basically, if you imagine us looking at a box turtle from above and you take a sort of angle that goes from back of the neck down to sort of the back area where the leg would attach, and you just take a massive slice, sort of very jagged slice out of the carapace. That's what we're sort of... It's massive damage it seems to have sustained. And I think you're probably bang on. It's got to be some sort of cutting... spinning blade that's caught them because it's a big chunk that has just been ripped along in this sort of fault line from head to behind the leg.
Yeah, it just goes to show these things are hardcore, mate. Like, what's the equivalent of that in a human? It's basically having like most of your shoulder
smashed ribs.
Yeah, because the carapace is just like ribs.
Take like 2/3 of your ribs and put a couple of centimeter gap between them going down.
It'd be like someone shoving a shovel up underneath your ribs on the left side all the way up to your shoulder and you just being like, yeah, cool, no worries. Pretty crazy. But really cool image and it got Christopher thinking about turtle boldness, which is kind of cool. All right,
but so this we're sort of saying, it might be bad for them in human areas, or if this is a sort of typical toughness of a box turtle, maybe it's only beneficial because they can just weather the storm because they're just tough little guys.
I don't know. I think boldness versus cars doesn't turn out well most of the time.
No, that's boldness. Nothing versus cars tends to turn out all that well.
Yeah, cool. All right. Well, have you got any other business beyond that? I have not.
Nope. That's it for me, I think.
Cool. All right. Well, in that case, if you want to become a Patreon, you can at patreon.com/herphighlights. Thank you, as always, to all our Patreons on there. If you want to get in touch with us, you can, herphighlights@gmail.com. I'm on Instagram, Tom_E_major. You can follow the podcast at herp_highlights on Instagram and TikTok. We're also on YouTube, so watch our faces if you haven't already. And I think all remains to be said is thank you for listening.
Yeah, thanks for listening.